Alright guys, we're in Unit 7, Lesson 2. Today we're going to be talking about equations of circles. So make sure to pause this and take down the notes. A circle is a round plane figure whose boundary consists of points equidistant from a fixed point, that fixed point being the center. The distance between the center of the circle and any point on the circle is called the radius. Okay, so that means if I have a circle and I got a center, the distance here is the radius. Now remember, if it's all the way across and through the center, remember that's called diameter. All right, so please don't confuse. Remember, radius is the shorter one. Radius is what we're going to be focusing on today. Because our goal is learning about the standard formula for a circle, which you can see here on the second line where I wrote in green. So it's the difference of x minus h squared plus the difference of y minus k squared equals r squared. Now the h and the k are it comes from the center, the coordinates of the center, excuse me. And then r stands for radius. Now the formula will show like the r squared. So if the formula has a 25, that means the radius is a 5, okay? Because in the formula, it's represented as radius squared. Okay, so let's take a look at example 1. Our goal is to write the equation of a circle with the given center and radius. So here, we're going to use the formula. So the center is my h and k, and then of course radius is 4. So the formula starts with x minus h, so I'm going to put x, and then I have a double negative for 4, so I'm going to change that to a plus. So make it x plus 4. Squared plus y minus k squared, and then equals 16. The 16 came from, if the radius is 4, in the formula you need to square it. Okay, let's try another one. So where it says x minus h, I'm going to put x minus 5, because we had h and k. So x minus 5, then squared, plus y plus 2, then squared. Notice it's y plus 2. In the point, it has a negative 2, but we're dealing with double negatives here. So be careful when you're dealing with formulas that have minus signs. And then equals 64. Okay, the 64 comes from 8 squared, again, because the formula has r squared. Okay, let's try another one. So we have x plus 6 squared for the hk, and then plus the y minus k would be y minus 10, then squared, and then equals 1. We got to put a 1 because 1 squared is 1. Okay, center 3 is 0, so the 3 is h, the 0 is k. So we would have x minus h squared, and then plus. Now, the k here is 0. So on the next line, we're actually going to clean that up. You wouldn't leave it like that. You would just put plus y squared. Okay, so don't leave the 0 in parentheses. And then the radius is 5, so therefore in the formula it must be 5 squared, which is 25. Okay, let's try another one. So hk. So we'll have h plus 4, double negatives change to a plus, then squared, plus y plus 6, again double negatives, also y plus 6, then squared, and then equals, and then take 7 squared, which is 49. All right, a little slightly more challenging here. So hk, it's slightly more challenging here because the radius is represented as a radical. And so we're going to have x plus 8 squared and then plus y minus 5 squared, and then equals, now we got to be a little careful here. 6 times the square root of 2 squared is saying 6 times the square root of 2 times 6 times the square root of 2. So 6 times 6 is 36. Square root of 2 times the square root of 2 is square root of 4, which is 2. And then 36 times 2 gets you 72. All right, let's continue on. We're going to write an equation, write the equation of a circle with the given stipulations. So in A, the points 2, 5, and whose center is 0, 0. So what's missing here is the fact that we're missing the distance, which is also known as the radius. So let's figure out what that radius is by using the distance formula that we learned the previous day. So remember, so what we'll do, we'll call this x1, y1, and x2, y2. So we're going to subtract the x's, and then squared, plus subtract the y's, and then squared. Now we're going to subtract, so that'll be negative 2 squared plus negative 5 squared. Now we're going to square those numbers. That'll be 4 plus 25 equals, add them, square root of 29. So that square root of 29, that's my radius, okay? So now I have the center, that's h. You got to use your center for hk. Don't use the 2, 5 for the formula. So you'll have x minus 0 squared plus y minus 0 squared equals, actually we're going to clean it up too. Remember the zeros, don't put them, so we'll just put x squared plus y squared. And then the square root of 29, we have to square that to put it in the formula. Square root of 29 times the square root of 29, the radicals cancel, and it's literally just the number 29. Do not carry down the radical with it. Okay, let's do some more practice here. We need to, again, we have a point and a center. We're missing the radius, so we're going to use the distance formula again to get the radius. So subtract the x2 minus x1, double negatives, squared plus y2 minus y1, another double negative, and then squared. All right, negative 13 plus 10 is negative 3. And then negative 16 plus 16 is 0. Now we're going to square those numbers. Negative 3 squared is 9 plus 0. And that'll be square root of 9, and that's going to be 3. So our radius is 3. So so now we're going to go to our formula. We're going to use the center point for our formula. It must be the center. It cannot be the other point. So we're going to have x minus h would be x plus 13 for double negatives, then squared, plus y plus 16, double negatives again, then squared, equals, and then we have to take the radius and square it. So 3 squared will be 9. Okay, let's try another one. Now, this one is going to be more challenging here. It's telling you the endpoints of the diameter. So it's like telling you this and this. We have no idea what the center is. So what we're going to need to do is figure out the center by using the midpoint formula. So that's why we learned it the other day. So we're going to start off with midpoint. Remember, it's a simple formula from yesterday. Flip back in your note packet if you need to. So you add the x's, then divide by 2. Add the y's, and divide by 2. So this will be, add them up, add the others, and now we're going to divide by 2. So 11, negative 8. Now that guy there, that's the center. These are the two numbers we're going to use for h and k in our answer, in our formula. So now, we still don't, unfortunately, know the radius. So what are we going to have to do? Well, just like we've been doing in A and B, we're going to have to use the distance formula. Now, we have to be careful here. Don't use the 2 points that are typed. You want to use one of the points, but not the other. You need to use, say, this 4, negative 3, and you need to use a center. Okay, remember that's very important for finding the radius, is to use the center and an endpoint. So distance formula, I'm going to subtract the x's. So 11 minus 4, and then squared. Can you take him to the restroom? Thank you. And then plus, subtract the y's. Negative 8 minus, not comma, minus negative 3, so that'll be a double negative. Squared. Okay, just double checking. 11 minus 4, negative 8 plus, okay. So now we are going to subtract there. So that'll be 7 squared plus negative 8 plus 3 is negative 5 squared. And then it's going to be the square root of 7 squared is 49 plus the negative 5 squared is 25. And then that'll be, add them up, and we'll get the square root of 74. So that's my radius. That's going to be very important. So let me highlight what we're going to be using for our formula. We have to use the center, that's our HK, and we have to use this to help us put our R squared. So it's going to start off with the formula. Again, I'm using this one right here at the top of the screen here. So x minus h, so x, h and k are here. So x minus h squared. The h and k always come from the center, remember that. Plus y minus k, but it's a double negative, so plus 8, and then squared. And then for the r squared, if the radius is square root of 74, remember that the square root of 74 times the square root of 74 is just 74. You don't need the radical in there. And there's your answer for an equation. Okay, let's try another one. So again here, all it gives us is the endpoints of the diameter. So again, that's the whole thing. We need to find the center. So we're going to need to use the midpoint formula. So we're going to add the x's, divide by 2, and add the y's, divide by 2. So that'll be 22 over 2 and 10 over 2 after adding. And then divide them each by 2, and we'll have 11 and 5. So again, that's my center. So that is going to be my h and k when I go into my formula. And it's also needed, remember your center is also needed to help you find your radius. And that's what I'm going to do now. So for the radius, we're going to find use the distance formula. You use your center, which is my 11.5, and then you're going to use one of your endpoints. I won't use 16.8, I'll use the 6.2. Again, the 6.2 is only being used twice here to find your midpoint and to find your radius. It's not going to go into your answer. So square root of, subtract the x's, so 11 minus 6, then squared, plus subtract the y's, 5 minus 2, then squared. Now we're going to subtract them, so 11 minus 6 will be 5 squared, plus 5 minus 2 is 3 squared. So we'll have the square root. Now we're going to square. The square root of 25 plus 9 is the square root of 34. So again, that radius, we're gonna need that for our formula for our answer. So let's go to our parentheses, x minus h. So x minus 11. We got that, top right of the screen up here. There's my h and k. So x minus 11 squared, then plus you're going to have y minus h squared, so that's y minus 5 squared, and then equals your r squared. Now careful here, the r is square root of 34, so square root of 34 squared, the radical cancels, and so you're just left with the integer 34. Okay, example 3, we're going to wrap this up soon. We're going to find the center and the radius of each circle. So it should be really easy. So the center here is 0, 0. Think hk. If there's no parentheses, that means the h is 0 and the k is 0. Now for the radius, we have to take the 2. Remember, that's in the equation form, that's radius squared. So to find the actual radius, we got to take the square root of 2. And just leave it in simplified radical form. Do not turn it into a decimal. All right, so again, h and k help us to find the center. So that would be 0 for the h, and the k is -1. Remember, we do the opposites for the center because of those minus signs that were in the formula. And then the radius, again, that is 5. That's the 5 is the r squared. So to find the radius, we have to take the square root of 5, which cannot simplify, so leave it like that. Letter C. The center is -3 and 5. It's -3, 5. And then the radius, you take the 38 from the formula, and you must take the square root of it. And that can only be broken up into 2 times 9. There's no 2 of a kind, so gotta leave it as square root of 38. Letter D, what's the center here? 0, 0. And then the radius, you have to take the square root of 72. Now I know this guy will simplify. So I divide using prime numbers, say 8 and 9. 8 can be 2 and 4 can be 2 and 2. And 9 can be 3 and 3. So remember, 2 of a kind can come out. So a 2 is going to come out, and another 3 is going to come out. And then that 2 that's not paired up that I just boxed in, that'll have to stay in the radical. So we have the 2 comes out times the 3 that comes out, and the box 2 that stays in. And then 2 and 3 that came out get multiplied to have 6 times the square root of 2. So there's your radius. Letter E, the center here, very easy, 0, -4, and the radius, square root of 11, which does not simplify. And letter F, the center is -2, 4. And then the radius, I got to take the square root of 50. Let me break down the square root of 50 on the side to simplify it. So that can be 5 and 10. 10 can be 2 and 5. So I do have a 2 of a kind in 5s, so 5 comes out. And this 2, there's no 2 of a kind for 2, so 2 is stuck back in. So your radius is 5 times the square root of 2. All right, guys, that's the end of Lesson 2 in Unit 7.